Welcome to Electronics Techies. So in this video we are going to discuss about Flipflop. So how we are going to design the Flipflop using Verilog. So first we have to know the functional table of the Flipflop. So it is like this. So D, Qn, Qn plus 1. So it is the present state where it is the next state. So 0, 0, 0, 1, 1, 0, 1, 1. So whatever the value of the Qn means present state, here the D flip-flop will directly assign the next state as D value only. Here the D value is 0, it will be assigned to 0. Here the D value is equal to 1, it assigned 1. So whatever the combination of present state means 1 or 0, it may be the value of D itself. So it is a Verilog code, it is a simple one amongst all the flip-flops. So module followed by module name. So it is our module name. So input. So what are the inputs? Clock. So according to your clock, your output is maybe going to be vary. So reset. Reset means if the reset value is equal to 1, so our Q value is going to be 0. Means it starts from initial stage. So its value is going to ascend to 0. If the reset value is not equal to 1, so our Q will be equal to D. Means what are the value of D is going to ascend to the Q. So output range. So why you make range means every time I say that what are the variables we are going to use in always block or initial block, it must should be a range data type. So that's why you make it as a range. Means why Q only means we are going to use this Q variable inside this always block. That's why you make Q as a range data type. If you don't mention it as a range, it defaultly takes 5. So you have to maintain it is a range. So that's why you make it as range. So these are the inputs and outputs. So this is the D, where it has a clock, the Q and Q bar. So these are the output. So this is the D flip-flop. Okay, so always there is positive of clock means for every positive edge of clock, this always block is going to be executed. So for suppose here we can see here the positive of clock will be going to happen means at this particular point the always block is going to be executed, and what are the statements inside this always block that is going to be assigned to particular values. So after this negative, there is no always block execution is happening here. Again, when it is going to be executed whenever the positive clock is going to be activated next time. So that's why only we can mention it is a sensitivity list. We can say it as a sensitivity list. So in the what are the variables we are going to use in the sensitivity list that are going to be execute, then only whenever there is a change in the sensitivity list input, then only our always block is going to execute. If there is no change, then it is not at all execute. So always if reset, what I say, if the reset value is equal to 1, so if you write like this, if reset means it directly take it is a true value. True value is nothing but 1. So if the reset value is equal to 1, so your Q is going to ascend to 0 else otherwise. So what will happen? Directly our D value is going to be assigned to Q. See here D values are going to ascend to Q. And what are the always begin? It will be end here. So module followed by module name. So next, this is our design test bench code. So module followed by here also module name. So this is the module name and range. So what are the inputs? You make it as a range data type, and what are the outputs? You make it as a wide data type. So why you don't make input variables as wide means there is a reason. So I always say that whatever the initial block and whatever the always block. So what are the variables we are going to use, that should be a, so what are the variables we are going to use, so that should be a range data type. So that's why see here clock, reset, D, we are going to use these variables inside the initial block. So there is no Q inside, that's why you make it as a while. So clock, reset, these are going to use in this initial block, that's why you make it as a range. So after that we have to instance the instance. So we have to instance the means we have to connect the design code with test bench code. So how we are going to connect means by using this line means we have to write the design code module line. So this is our design code module name. Design code module name followed by instance name. You can make any name as you wish. DUT means design under test. So followed by port list. So port list means port connections by order. How we are going to connect these order means, so see here what is the order here, clock, reset, D, Q. So these are the variables in design code. So what are the variables in test bench code? Clock, reset, D, Q. If you follow the order, so first what are the variables we are going to write here? This clock is going to assign in the design code of this clock. So for suppose if write reset comma clock comma Q comma D like that. So what is happening is these reset is going to be assigned to the first variable in design code. There is a clock. So means clock is connected to reset. So there is a mismatch. So when you are going to use this order, you have to must follow particular thing. Otherwise it will go into wrong connections and it may be give wrong answers. You think your design code is wrong, but not your design code, your connections will be mistake. So just understand this concept. There is a separate video I have already done about the port connections. You have to watch that. Then you have any queries, you can make it as a comment. So initial begin. So after this you have to write the initial begin. So what is the initial begin means? There is a different input combinations you have to give. You have to give different input combination inside this and verify your output is whether correct or not in the waveform or in display statement also. So clock. So first initially I give clock value is equal to 1 and the reset value is equal to 1. Means if the reset value is equal to 0, what will happen? Your Q is directly equal to 0. So I have to give different combination and after some delay I give some other different combinations and again some delay I give different combination at particular and finally I use finish keyword. So why you use this finish keyword means stop the simulation. For stopping the simulation use this finish keyword. So end. So what are the initial begin? This will be end here. Always slash by clock equal to invert of clock. So clock I give 1. So it is not only be 1. So for every 5 nanoseconds of time it is going to be toggle like this. So that's why I have to write this statement for toggle. So you have to change our clock by toggle means first time clock equal to 1. Invert of clock means 1 is going to be 0. So for every 5 nanoseconds 0, 5, 10, 15 for every 5 nanoseconds your clock is going to be toggle. So after this I write 4 lines. Every time I say that whenever you are going to observe waveform in EDA playground. So you have to write these 4 lines. If you do any if you do this code in Vivado or any other thing, you have to simply ignore that and followed by module and a module. So this is our simulation output waveform. So initially clock equal to 1 and there will be toggle like this. I already said that. So here we can see reset value is equal to 0. What I say, the reset value is equal to 0. What are the value of the D? So here the D value is equal to 1. But what is our output? Q value is equal to 0 means it doesn't care about D value. It simply take it as a output as 0. So that's why the reset equal to 0 or Q will be equal to 0. So then see here the reset value is equal to 0. What will happen? Your D is assigned to Q. See here D value is equal to 1. That will be assigned to Q equal to 1. So after again I give every passage of clock. So you see here, here passage of clock, what will happen? Your D value is equal to 0 and your Q value also going to be 0. Like that, if the reset value is equal to 0, then it doesn't care about Q value, your output is simply equal to 0. Sorry, if the reset value is equal to 1. So if the reset value equal to 1, your Q will directly simply equal to 0. It doesn't care about D value. If the reset value is not equal to 1, means that means 0. So your Q value is equal to 0. 3. D, sorry. D. So like that we are cross check whether your code is correct or not and get correct waveforms or not. So if you have, while you are doing code, if you have any errors or try to rectify that, if you also then also you don't understand this, you simply comment on it and make a separate same small video on that particular doubt also. So I think it's fine about Flipflop and thanks for watching and thanks for keep supporting me and then bye.